Okay, hello everyone. In this video I'm going to show you how the Jetson Jetson Nano device performs with a Docker container running yolov5 in object detection. So I created this Docker container in order to avoid conflicts with the host operating system and to have a kind of a sandbox in which we can run whatever we need, or maybe also different models for object detection without affecting the outside operating system. In order to run my Docker container, we need to first, well, let me show you. Doc.sh, okay. We need to start the Docker image that I created by using this rather complex command, because we need to mount something in some folders, to share some folder between inside the application and the outside world, and we also need to map the display to make the camera device accessible and so on. So there are some settings that we need to use, and so when you type this command, what you get is that you have a starting instance of my container. So here we have more or less the same data that I had outside, because it's what I copied with my Docker file when I created the image. So here what I'm going to do is that I'm going to start the application. So we have two different types of application at the moment. I'm going to show you both, because the first one is rather faster than the first one, but has a worst aspect. It means that the fonts are not so good, the quality of the picture is not what I would expect. But we have a work in progress version which is going to improve a bit the output, and so I'm going to show you both. So the first one is the worst, let's say worst version, but works a bit faster. It's just run by typing detect UI. Okay, this image. Okay, this image, as you see, loads the YOLO model from the disk and loads also the weight that I've been training on another platform, because it takes too long to work on the Docker in training, and I imported this model onto this platform, onto this device, so that we can load the weights, and then we perform inference and we detect electronics component in real time over a board. As you can see, it takes a bit to start up, but when it works, we can have a detection with a frame rate of 2 frames per second, which is not bad, considering the fact that this is a very, very tiny hardware platform. So when I move the board, you see that it gets updated. We have still a lot of some mistake, because you see that coils are not always detected correctly. Sometimes there are mistakes, but it's reasonable, because the training has been performed only on 20 pictures, so it's a very small training data set, and considering that usually we should be using 400, 500 or even more pictures to train the model, so this is a very good achievement. So as you can see, we have, well, the font is not so good, so the text cannot be displayed very well in this version. So what I'm going to quit the application now and start the other one to show you the difference and to show how it performs. It's slightly slower, but in my opinion it's much better in terms of user interface. Okay, this is the work in progress application. It takes still takes a bit to load, as you can see. we're still reading the model. It's the same exact model. We are working on the same model as before, so there's no difference at all. After a while, you will be seeing it working. Okay. We should be seeing the interface soon. Okay, now it's here. You see that we have better fonts. We can use TrueType fonts in order to display our text, and we can also increase the size of the window. That was doable also with the other version, but I didn't show you. But you can increase the size of the window, you can move the windows around, and you can still change the orientation of the board in order to detect additional components. So you see it takes a bit more in the update, and still we get errors because well, the training, as I said, has been done only with a small, very small data set, training data set, but the results are pretty good. So you see here, well, we can eventually implement some filtering, remove labels, but you can stretch and reduce the window size, and the window size is limited to a minimum size beyond which we cannot go. So less than this we cannot reduce the size of the window, but it's just to make sure that we still have a view on what we need. And in this case, still we get 1 frame per second, so it doesn't worry too much about the size of the window. The performance is more or less the same. I think this is lower because it uses TrueType fonts and requires a bit more complex displaying of the images, but of the stream. But still, it's good for the platform that it's very, very tiny. Thank you for watching.